breast cancer prediction. So myself, Amelsha, my team members are Akhil, Kumar and Rohith. So now I'll go to the introductory part of our project. First of all, I will tell about the objective. So our objective is to develop a model to classify breast cancer as malignant or benign, aiding early diagnosis for better patient outcome. Then about the data set, we downloaded it from the Kaggle for creating our model. Then the tools we use the Python libraries such as pandas. It helps for data manipulation and processing. Then the sklearn. It helps for building and evaluating our machine learning models. Then the last one, Streamlit. It helps to create simple interactive web application. Then our goal is to compare models to find the most accurate classifier for reliable breast cancer prediction. Then the problem definition. So the problem being addressed here is to predict and classify breast cancer cases as malignant or benign for early diagnosis. For this, we are taking two assumptions. The first one is our dataset is clean and accurately labeled. Then the second assumption is selected features effectively distinguish cancer types. So then I will tell about the relevance of our project. The first relevance is support timely and accurate patient diagnosis. The second one, it enhances the healthcare efficiency by reducing the diagnostic time. Then it contributes to the broader tech-driven early cancer detection. Then I will explain our data features. So the first feature in our dataset is clump thickness. It measures the thickness of cell clusters indicative of tumor compactness. Then the uniformity of cell shape. It reflects the consistency of cell shape with abnormalities suggesting malignancy. Then marginal addition assesses how well cells adhere with lower addition linked to malignant cell. Then the single epithelial cell size indicates size variation in epithelial cells, a key cancer indicator. Then the bare nuclei is an important feature. It refers to the nuclei without surrounding cytoplasm, often found in malignant cases. Then the bland chromatin. It evaluates the texture of the cell nuclei with variation suggesting malignancy. Then the normal nuclei counts nuclei within cells. Abnormalities may point to cancer. Then last independent feature is the mitosis, measures the rate of cell division. Higher rates are commonly seen in telomeres. Then the last feature is the class, that is the target variable. So here the 0 represent the benign cases and the 1 indicates the malignant cases. Then I will explain the data pre-processing techniques. So three data pre-processing techniques are used here. The first one is handling missing values. So we will fill or remove any missing data points, especially in features like bare nuclei. Then the second method is encoding target variable, ensuring the target variable, that is the class, is binary and appropriately labeled. Then the last technique is splitting data. We are dividing the data into training and testing sets to evaluate the model performance. So then I will explain the code. So here we can see that first we are importing the necessary libraries required for developing our model. Then we are importing our data set and assigning to a variable df. We can call df as data frame. Then we are checking the dimension of our data set. That is, here we can show that shape function is used for seeing the dimension of our data set. So here we can see that 674 rows are there and 9 columns is there in our data set. Then we are calling the info function to our df. Then we can see that all the features there, data type, count, null values can be seen by calling the info function. Then the first data processing technique, that is, we have to handle the missing values. For that, this function is called. then we can see that all the features and the number of missing values. The count of missing values is here. So here we can find that there is no missing values for any feature. Then we are describing that features, that is every feature is there, clump thickness, uniformity of cell shape, marginalization, every feature is there, and we are checking their count, mean, standard, minimum, 25%, 50%, 75%, and maximum. For that, describe function is called. Then we are calling the head function. So it will take the first 5 data points. Then we are visualizing our class. So here we can find that in the X, it is representing the class and the Y, it is representing the count. So in the visualization, we can find about benign cases is for 430, and the malignant cases, we can find that the count of malignant cases is 240. So this bar plot is used for visualization of our class. Then we can see the scatter plot. Another visualization. So here in the X we are calling the clump thickness and the Y we are calling the marginal addition. Also we are calling the hue function to our class. That's for we have to separate the different classes. For that, in this case the benign has given blue and the malignant case has given yellow. We want to separate that two classes. For that, this hue function is called to class. Then this is the representation, visual representation of our two features. So this scatter plot will help you to visually access if there is any separation or pattern between benign and malignant cases. For that, we are using two X and Y, two features, marginal and addition. And also in the second visualization, we are changing that two features to single epithelial cell size and the mitosis. So these two is represented here. Then we are going to the second pre-processing task. That is, first one we already see that handling the missing value. Then we are checking the encoding target variable. That is, we can see that in the data set, every feature except the class feature, every feature is in a numerical data format, but in the class it is in a categorical data format. So we want to encode that. So we are using label encoder for changing it. So we are calling label encoder to our class. Then the last data pre-processing, that is splitting the data. For that, I am calling ilog. So the ilog is used for index-based selection in pandas. So on the in the X variable, we are assigning the all the rows and all the columns except the last column. That is mainly before comma there is nothing, so we are taking all the rows, and here we can see that we are taking all the columns. It's the -1 represent except the last column. That way I call that in the X variable we are taking all the columns and all the rows and all the column except the last column. So actually as a result, X value is containing all the independent features. Then the Y column, we can see that it is taking all the rows. It is selecting all the rows of last column. So as a result, the Y is containing all the dependent feature. That is, class label is in the Y label. Then this function xtrain, xtext, ytrain, ytest, train, test split. So this function is used to split the data for testing and training. From we are using this function from our sklearn library. Then we can see that we are checking each dimension of our train data, that is xtrain. We can see that 80%, sorry, in the splitting time, we are splitting the testing data is 20%, and for training, it is taking 80% of the data. So here we can see that if we show the if we see the dimension of our xtrain, that is for training, it is taking 80%. So the 539 is the 80% of our data. Then X is for independent feature. So there are 8 independent features, so that it is 539 and 8. Also Y train. So Y train, Y shows the dependent feature. That is only one is their class. So there is one, that is nothing is there. Then 539 also for training 80%. That's why 539 there. Then the X dot shape, X text dot shape. So in their X, so X already I said that it is individual feature. So it is there. Then for testing, it is 20%. So the 20% is the 135 in the y test dot shape. Also there is for the test. It's y that is dependent. There is only one class. There is nothing. So also for testing 20% 135. So this all are the dimension of our training and testing data. So next, the model building. It will be explained explained by my friend Agil. So
Hello everyone. I will be explaining from model selection. So model selection. So for this particular project, we have used mainly these three models, which are logistic regression, decision tree, and random forest. And also we have checked cross validation scores for each and every models we used for this project. So we will be talking about the architecture of logistic regression and how logistic regression works. So uh, before looking into logistic regression, we should know how linear regression works. So in linear regression, we assume that there is a linear relationship between the independent variables and the dependent variable. And we are plotting a line segment which uniquely explains the relationship between the independent variable and the dependent variable. So in logistic regression, we'll be using as something called sigmoid function, whose value is 1 by 1 plus e raised to minus y, where y is the equation of the line segment, y is equal to mx plus c, where m is the slope and x is the input and c is the intercept. So what happens in sigmoid function is that the the value the output value will range between 0 and 1, and the uh, the output will be in the form of a S-shaped curve, also called sigmoid curve. In linear regression, it was just a line segment, but in logistic regression, we will get this curve. So, logistic regression is used for binary classification. So, how it predicts the classification? In logistic regression, there is a threshold value. Usually, it is 0.5. So, if the output is above 0.5, it will belong to one class, and if the output is below that threshold value, it would be the other class. So in our case, if the value is greater than 0.5, then it would be malignant case, and if the value is below 0.5, then it would be benign. So talking about the advantages and limitations of logistic regression. So the advantages are first, logistic regression is easy to understand. And second, it is very efficient when we are working with a small to medium sized data sets. And it is very good for binary classification problems. Some of the limitations are we assume that there is a linear relationship between the independent and dependent features. And the other limitation is it is sensitive to outlier. That means, suppose if there is an outlier in our data set, so the accuracy will be significantly reduced if an outlier is present in our data set. So that is a biggest disadvantage of logistic regression. And also, this logistic regression model is not suitable for complex problems. So if our data set is having a huge number of independent variables, then we should go for some other models like decision trees and neural network. So that's all about logistic regression. Next one is decision tree. So in this project, we will be using decision tree classifier. So the architecture of a decision tree is tree is structured as a hierarchical tree-like model that splits data into branches to make decisions. It classifies data or predict outcomes. The components of a decision tree uh, classifier is first is the root node. The root node is the top node of the tree and represents the entire data set. At the root node, the algorithm evaluates all features to determine the optimal initial split based on the highest information gain or least impurity. So examples for this are Gini impurity or entropy. Then the second component is the decision nodes. There are the decision nodes are the uh, internal nodes of the tree where the data is split based on feature values. Each decision node of the decision tree represents a test or condition on a feature, branching the data into subsets that follow different paths. Uh, the splitting criteria would be based on methods like Gini, impurity, entropy, or variance reduction, depending on the type of decision tree we are using. So in this case, we are using classification. So we can go with the Gini impurity. Then the other component of decision tree is branches. So branches connect nodes and represent the outcome of the test at a decision node. Each branch corresponds to one of the possible values or ranges for a feature, guiding the data down the tree based on how it meets the condition at the node. Uh, Next component is the leaf node. There are these are the terminal nodes that represents the final decision or outcome of the tree. Once the data reaches a leaf node, no further splitting occurs and the output is provided. So this is all about decision tree. This is how the architecture of a decision tree is. So one of the uh, problems with the decision tree is that the decision tree is a weak learner. Weak learner is a machine learning model that performs only slightly better than random guessing on a specific task. So decision tree is not reliable. Then the other disadvantage is there is a possibility that overfitting can occur. So these are the two disadvantages of a decision tree. But we can use the weak learners like decision tree to form a strong learner by using ensemble methods. In by like for example in random forest. So we also use random forest in our project. That's the next model. And this is the architecture of a random forest architecture, random forest classifier. So what happens in random forest classifier is that we will be combining n number of weak learners. We'll be using decision tree in random forest. So we will be having n number of decision trees which are combined together, and the whole data set is split according to the number of decision tree we are using. Suppose if we have 10 decision trees in our random forest classifier, we will split the whole data into 10 parts, and each part is fed to each one of the decision tree models. And suppose six of them predicted the output as yes, and four of them predicted the output as no. That means we can in how the output we take in random forest is like we will go for voting or averaging process in which we will count the number of models which have predicted the output as yes, and we will count the number of no's. And if the number of yes is greater than number of no, for example, in our case, 6 is greater than 4. So the output of our random forest classifier model will be yes only. So like that, we are combining the outputs of some weak learners in order to form a strong learner model. So this is how the random forest works. But if we can also use random forest architecture for regression tasks also. But what is difference in regression random forest is that instead of taking the voting, we will go for taking the average. So in regression models, in regression tasks, we will be taking the outputs of every decision tree models, and we will take the average value, and that would be the output of a random forest regressor model. So this is how a random forest model actually works. So this ensemble method increases the accuracy, and also it reduces overfitting. Yeah, okay. Now talking about the results and discussion, we see that logistic regression is having 96% accuracy, decision tree is having 93%, and random forest is having 97% accuracy. And these are the confusion metrics of these individual models. And these are the classification reports of logistic regression, decision tree classifier, and random forest classifier. So now I will show the code. So this is the code. The necessary libraries are imported at the first line of code itself. This is the model building part. The first model is logistic regression. So I did the cross validation also to make sure that the model is not overfitting. So I fed the data to the model, and the model gave me an accuracy of 96%. And this is the code for the confusion metrics of this model. And this is the classification report. In model 2, I used decision tree classifier, and his variable's name is model 2, and I fitted the uh, data to the model, and also did the cross validation, and everything was okay. So I moved further and got to 93% accuracy. So this is the confusion metrics of decision tree. This is the classification report. And this is the model 3, that is random forest classifier. So I fed the data to the model 3 and did cross validation. And here also cross validation says it's fine. We don't need to do anything on the data. So I moved further and I uh, checked the difference in the predicted and the actual, and got an accuracy score of 98. So this is the uh, confusion matrix, and this is the classification report of uh, random forest classifier. So next part will be presented by my friend Rohith.
Hello. So now I will further discuss about the result and discussion. So the according to the report, the accuracy score for random forest is higher, but we choose logistic regression because because as this is used in medical projects, the number of false negative should be lesser. So so as a result, we use logistic regression. As the number of false negative is less, and it provides a better performance too. So in this confusion matrix, first we are discussing about logistic regression. We have a value of true negative. We have 89 for true negative and 41 for true positive, and false positive we have 4, and the value for false negative is 1. So the confusion matrix for the decision tree classifier is given as 89 for true negative and 40 for true positive, and 5 for false positive and 1 for false negative. When it comes to the random forest classifier, we have true negative 80. We have 88 for true negative and 44 for true positive, and the false positive is 1 and the false negative is 2. So here now we'll discuss the classification report. So here classification report of logistic regression. So here we have 2 classes, 0 and 1. So the precision, first column, it is precision. It is the ratio of true positive to the total predicted positive for each class. And for 0, we have 99% of instances. And for class 1, we have 91%. And then recall. Recall is the ratio of true positive to the total actual positives for each class. For class 0, we have 96%, and for class 1, we have 98%. Then F1 score. It is the harmonic mean of precision and recall, providing a balanced measure of the two. For class 0, it is 97%, and for class 1, it is 94%. And support is the number of true instances for each class in the dataset. For class 0, we have instance of 93, and for class 1, we have instance of 42. Then the model's accuracy is 96%, 96%, and the macro average that is calculates the average precision, recall, and F1 score of values 95%, 97%, and 96% with the support 135, and the weighted average. The weighted average gives the value of 96% for precision, and 96% for recall, and 96% for F1 score, and 135 for the support. So the next is for decision tree classifier. For decision tree classifier, the precision for class 0 is 99 percentage, and for class 1 it is 89%, and for the recall it is 95% for class 0 and 98% for class 1, and for the F1 score it is 97% for the class 0 and 93% for class 1, with support of 94 instances for class 0 and 41 instances for class 1, with the accuracy of 96 percentage and support 135, and the macro average for the precision, recall, and F1 score is as follows: 94%, 96%, and 95%, and the weighted average for precision, recall, and F1 score is 96%, 96%, and 96%. So the next is random forest classifier. So the precision for class 0 is 98%, and for class 1 is 98%. And for the record, for class 0 it is 99%, and for class 1 it is 96%, and the F1 score for the class 0 is 98%, and class 1 is 97%, with the support instance of 89 for class 0 and 46 for class 1. The accuracy is of 98%, uh, and the macro average for precision, recall, and F1 score is 98%, 97%, and 98%. With the and the weighted average for precision, recall, and F1 score is 98%. For both for three of them, it is 98%. And conclusion. So in our project, we explored several machine learning models, each with its own strength and weaknesses. Uh, and logistic regression emerged as the best choice based on its simplicity, interpretability, and performance. Compared with other models, logistic regression model has lesser number of false negative prediction, which is very important for our case, making it natural fit for our project. Additionally, logistic regression provides probabilistic output, which can be very useful for understanding the confidence of the prediction. So we exported the train logistic model using the pickle file and deployed the model using Streamlit library. Okay, and now I will show you the code. So here we import Seaborn and Matplotlib for the visualization, and the sklearn matrices for the accuracy score, confusion metrics, and classification report. Uh, so yeah, so here we use plot plt.figure. It creates a new figure with a specific size for the plot. And SNS heat map, this line uses the Seaborn library. Then plt.x label, it sets the label for the x-axis, and plt.y label sets the label for the y-axis. PLT title, it sets the title as a confusion matrix, and plt.show is used to display the output. So this is how we show the confusion matrix for linear regression. And similarly, we are using the same method to display the other methods as well. This is of decision tree classification, and this is used for random forest classifier. Now and then we use pickle.dump so that we can export the train logistic model pickle library to the app.py. Now this is the code of the app. So we import the libraries Streamlit, Pandas, Pickle, and Base 64. Here, function set background is defined to set a background image for the application. And then we use get user input function. it is typically a server to gather input data from a user. In our project, this function could be designed to collect medical features relevant for predicting breast cancer. So now I will show you how we run the program. Uh, okay. So this is our prediction application. So we can either enter the numbers just like this, or we could increase the number using this plus sign, or if you want to decrease the number, we could use this minus sign. So now I'll just enter the numbers. Uh, So here the prediction says that we have that the user has a cancer. So we can if we reload it, the numbers will be back to null, and we will predict it once again. So here we go. So by tapping predict, uh, yeah. So this is the other output in which the user doesn't have a cancer. So that's it. And now we also used so these are the references that we have used. Uh, the power of decision table by Kohavi R, induction of decision tree machine learning by Quinlan R, then generating accurate rule sets without global optimization by Frank E and Ian H. Witten. Then scaling up the accuracy of Naive Bayes classifier, a decision tree hybrid by Kohavi R. Then instance-based learning algorithm machine learning by Aha D and Kibler D. So that's all. Thank you.